So there can be other ways too. You can just directly find out the distribution of x, y, and then you can find out x plus y from there. Okay. Or you can just find out, so you can see you need to find out, there are other way, there are different ways too. You need to find out variance of x plus y, right?
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science.
So you can find out x plus y distribution. Yes, you can find x plus y distribution. That's easy. You can find the variance of y and the y distribution, and then find the variance of y. Yeah, but essentially, again, it's like a long procedure of action to get to the same thing. When can you write expectation of x y, x given y, expectation of x? So first, do you know what is the meaning of expectation of x given y? That's my question. Who knows the meaning of expectation of x given y? That's the main question. So let's try to understand what is this. So expectation of x given y is equal to y. So if you have a two-dimensional distribution, let's say, you have a normal distribution like this, two-dimensional. Okay, it's a two-dimensional distribution, normal. This is x, this is y. So expression of y given, so you know that x given y is equal to y is a random variable itself, right? So what is expectation of y given y? So y expression of y given y is nothing but these, you fix y here, this is a y value, you, or let's say you fix a y value here, you draw a line, a plane here. Now this plane will project, it's like cut the whole distribution in the middle, in that sense. Okay, cut this at the middle point, at this point, cut it like a plane. So naturally, if you cut it like a plane, imagine a 2D object like this, cut it like a plane, it will naturally give an idea of the distribution, right? That will, it will naturally give a curve, but the area under the curve is not 1. So this is nothing but, whatever you get after cutting is nothing but f of x comma y, right? But this one, all these points, because y is fixed, x is varying. So this is f of x comma y is fixed. But this is not, so not x comma y, but like this, I should say. At every point, it's, so now for a given point, now the area under the curve is not 1. So what they do is they divide by the area under the curve. If you divide by the area under the curve, is nothing but the f of y, like the density of the f of y. Okay. So therefore you divide by it to make it 1. So that's why it's defined as f of y given x is equal to, or let's say x given x y is equal to y of x given y small y is nothing but f of x comma y, the joint distribution of x comma y, divided by the area under the curve. That is the, so this is the cutting plane. So it's actual value of this. Now the area under the curve is not 1, so therefore what it does is it just integrates all over it to get the area under the curve, and we get this. All of you understood this, yes or no? Did you understand this? So we cut it in the middle, we get this at y is equal to y, we get this. We now see the area under the curve is not 1, so we divide by f of y, which is the area under the curve. So because y is the area under the curve, because it's integration over x f of xy, and this is nothing but the x coordinate, right? Because y is fixed. So therefore we get this part, right? And therefore its sum is 1. Now naturally, so this leads to a distribution or random variable x given y is equal to y. And naturally, if there's a random variable x is equal to y given y is equal to y, x given y is equal to y, naturally there's an expected value. But what is the random variable here? What is the meaning of this? That's my question. So it's easy to understand this, but what's the meaning of this? So naturally understand this, that This expression of y is equal to y given y is nothing but a function of a small value y. Y is given, so it's a g of y, right? That means a function of y, the value of y, small y. So what they did is that scientists, this statisticians, they whatever mathematicians, they saw that, oh, this is coming out to be g of y. For example, in this case, it was coming out to be normal of x given y. It's coming out to be expression of y given y is coming out to be x, right? So they saw that gy is equal to y in that case. So what they did is that they defined that this is a definition. Okay, this is not an understanding. They defined this to be this is a symbol of definition. They defined it to be g of capital Y. So they defined it to be g of capital Y. It's why, because whatever the output is, it's nothing but a transformation of y, right? Small y. If you input this small y, the output is something transformation of y, small y, right? So therefore, so therefore expression of x given y is nothing but a function. So therefore, what is this? This is nothing but a function that is taking in the from the sample space of y to some real number. That means what? It's nothing but a function that changes y. That means it's a function of y. You see, therefore, it's nothing but input is small y, the output is something else. So therefore, if it's something, if you take input y and output something else, that is the function of y, right? And since y is the variable, which is nothing but an outcome of capital Y, therefore it is nothing but a function of capital Y.
To book a trial class for your preparation courses of IIT MS, ISIM Stat and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.